Hello and welcome to Physical Sciences. Today our focus is on the classification of matter. My name is Themba Ncube. By now we probably familiar with that anything that exists around us is actually a form of matter. Put simple, we know that matter is everything, and everything around us, physical or otherwise, is a form of matter. Without any waste of time, let's look at the big ideas that have to do with matter in terms of the concept map, or some of the very important aspects that relate to matter. Right. Okay, so we talk about the composition of matter. So matter is actually the big idea. So if we talk about the composition of matter, we actually asking ourselves, what is it exactly that makes up matter? And we also know that by now that matter consists of pure substances, okay, pure substances that are actually divided into two broad categories, which are elements and compounds. We'll look at each one of them in more detail as we go along. But our major focus today is also to look at the physical properties of matter, which determines exactly why we use certain types of materials for specific purposes. Also, ultimately, we'll look at the various types of mixtures, which is the homogeneous as well as the heterogeneous, and how these exactly differ from what we would refer to as pure substances. Right. Okay. Now, the thinking activity is something that's going to guide us. So there are two broad questions that we would want to put out there, So by the end of this session, we must be able to arrive at some form of understanding in terms of responding to these, big questions or big ideas. So we must think along the lines of saying, okay, have you ever thought about what properties of matter, okay, influence the choice for their use? So we want to relate use of a particular type of matter or material, based on its physical properties, or the type of properties that a specific form of matter actually has. And then the second question centers around the idea of why matter exists in different forms. Okay, so these are the big ideas. We're not going to go further into detail, but the discussions that we're gonna have would most certainly, in more ways than one, try and address these big questions. All right. Okay. Now the terminology. There are some keywords that we'll definitely use once too often than others. We need to also understand their meaning in the correct scientific context. Okay, so the terms like classification would say we are classifying matter either into pure or impure substances, mixtures, into homogeneous as well as, heterogeneous. So classification, in other words, we can say we are categorizing different forms of matter that will be given to us. Right. So we'll talk about classification. Now we also talk about matter because this big topic is about matter. So matter is everything that has got mass and volume. And in other words, matter does occupy space. So we talk about matter in the context of everything. Okay. So everything around us is matter as long as it occupies space and it has got mass. So material will be used interchangeable to refer to matter. So, matter is a broad term, and then material becomes specific to a certain type of matter. Right. Okay. Now, under classification of matter, let's understand that matter is quite a broad, term. Okay, but we can further break it down, into simple terms and say, okay, if we have a given type of matter, we can classify it into two broad categories. Now, what are these categories? We've got pure substances as well as impure substances. So, given any form of matter, it can either be a pure substance or an impure substances. But then how then do we get to say, okay, matter X or material X is actually one of the two categories? It's based on the properties that we shall discuss further in detail. Right. Okay. Okay. Now the other keyword that we will meet once too often or use quite a lot in our discussion for this session is pure substance. So a pure substance is a form of matter, okay? So let's think of it as a form of matter, okay, which falls into one of those two categories, and then this is a form of matter, right? So a pure substance is a form of matter, okay? And pure substances are either divided into elements and or compounds, okay? So in short, what we are simply saying, if you've got a pure substance, two things can happen. A pure substance, whatever it is, it can either be an element or a compound. I think even from our, our earlier interaction with matter and materials, because this broad topic is not entirely new to us. At some point or the other, we spoke about, the term element in terms of, the periodic table of elements, which is something that we shall also try and look into more into detail as we go along. And then again, we spoke about compounds, which is made up of elements. So elements and compounds are forms of matter which are classified under the broad category of pure substances. Okay, so we'll use these key terms quite a lot, right? And then matter is pure substances, okay, or impure substances. And then under pure substances, we can either have a substance being an element or a substance being a compound. So both elements and compounds are actually pure substances. So we can say elements and compounds. This is what this is a conclusion that we are actually arriving at, are pure substances, okay? That's a fact, okay? So elements and compounds are actually pure substances, okay? And pure substances are actually a form of matter, which is one of the two broad categories, okay? So now, when we talk of impure substances, impure substances are substances that can be mixtures, okay? Mixtures are further divided again into either homogeneous or heterogeneous. So the word homo actually means uniform, while hetero means, non-uniform, okay? So impure substances are actually mixtures. So in short, we can also say mixtures are impure substances, okay? So the main idea here is to try and classify, okay, or categorize. So we're saying that pure substances are either elements or compounds, and then impure substances are actually are mixtures, and mixtures are further divided into two categories, okay? Right. We will also look at individual properties of each one of those. So this is the big idea in terms of classifying matter in general. Right. Now, let's look at mixtures, okay? The word mix in itself, it says a lot in terms of having a lot of components coming together, So it's more than one type of a substance within the same space. It could be a container, it could be anything. And ideally, there are real life or everyday life examples that we'll use to try and bring an understanding of what exactly a mixture is and what is it that separates a mixture from other pure substances, which are actually elements and compounds. But there are also differences and similarities that we need to pay careful attention to in as far as classification is concerned. Right. So we are saying that a mixture forms when two or more, okay? So it's more than one substance, okay? They are combined. It could be in the same container and mixed physically, that's the key word, okay? Without them chemically bonding. So in a mixture, typically what you have, you've got more than one substance. It could be any number of them. And then these two or more substances are actually put within the same container. They don't chemically bond with each other. They retain their properties. So that's a mixture. So a mixture is actually made up of pure substances that are not chemically bonded to each other. That's the main idea that I think we definitely need to point out. Right. Okay. So that's as far as a mixture. So what are some of the properties of a mixture? Now, the moment we start talking about properties of a material or of a type of matter, we are definitely going to look at each one of them, and then these properties would determine whether that mixture is either, a homogeneous mixture or a heterogeneous mixture, or largely whether that substances or that material that is given to us is either, a pure or impure substance. But generally, all of them are just described or are referred to as matter. So properties are going to assist us in terms of classification as well. Okay, so in a mixture, components are not in fixed ratios. Okay, what that simply means is that we don't have to have a fixed amount of each of the individual substances that come together in a mixture. It can be in any ratio. You can have 2 parts of substance A and 10. In the other case, you can have 5 parts is to 3. It doesn't matter. That's what exactly it exactly means when we're saying that these are not in fixed ratios. Okay, that's a very important property or a characteristic of a mixture. And again, these individual components that make up a mixture, they still keep their properties. Hence, we're saying they retain their properties. So if substance A in a mixture of A and B are together, it's still substance A. If it was sugar, it will still taste sweet. If it was, something that is sour, it will taste sour, even if it's in a mixture. Why is it so? Because these substances did not chemically bond with each other to actually form new substances. As a result, they actually retain their individual properties within a mixture, right? Okay, and then thirdly, it says here, components can be separated by using physical techniques, okay? Now, the point that we're trying to make here is that within a mixture is reversible. And at some point, we are able to say, okay, we want to extract substance A from a mixture of A and B. Okay, so mixtures are actually reversible. We can actually separate the individual components that actually make up that mixture. So mixtures are not permanent. But also bear in mind, that is only possible because of the fact that these substances did not chemically bond with each other to form other substances, making it irreversible. So mixtures can be separated by using physical techniques, right? And then in terms of the 2 categories of mixtures, we've got homogeneous as well as heterogeneous mixtures. The word homo means uniform, okay? So the word homo suggests that the mixture is uniform. We'll talk to that in more detail in terms of what exactly it means. It's uniform in what respect, okay? Hetero means non-uniform, okay? So that those are our catchwords, right? So a uniform mixture is a homogeneous one, while a non-uniform mixture is a heterogeneous mixture. And a mixture is actually an impure form of matter, okay? So these are impure substances or materials, okay? We can think of it that way, right? And then in terms of the homogeneous mixture, we have identified that what stands out about a homogeneous mixture is that the composition is uniform, okay? We'll talk about that. So when components of a homogeneous mixture cannot be distinguished from each other, they're actually in the same phase. Most solution, as a practical example, if you take your water and your sugar, of which the sugar is completely soluble in water, it forms a homogeneous mixture. So that's a uniform mixture. And now within that solution, we are not able, or we are not in a position to say, okay, these are the sugar particles that make up the sugar, and then these are the water particles that make up, or the water molecules. So if we cannot distinguish between the components that make up that mixture, then that particular mixture is actually a homogeneous mixture. Okay, straightforward. And then there is a typical example that we spoke to with respect to a solution. So most solutions are actually homogeneous mixtures, right? Okay. Now let's talk about another practical example of a homogeneous mixture. We know that A is actually a mixture of gases. What that simply means, because the word A is usually used to actually refer, to any gas, we would say it's A. But A, in essence, it's actually a combination or a mixture of different substances, okay? But these substances, what is actually common about them is that they are in the same gaseous state. Hence, would refer to it as a homogeneous mixture, because we cannot separate, the nitrogen molecules from the chlorine, from the argon, the oxygen, the carbon dioxide. The list goes on. So, as a result of that, based on those properties, we can actually say that yes, indeed, air is a typical example of a homogeneous mixture. Okay, right. So, if you look at the pie chart there, it talks about the proportions of each of the individual substances that actually make up that mixture. 78%, nitrogen, 21, and also there's another combination of many gases which makes up 1% of air as an example. And then we also have alloys. Alloys are mixtures of metal, okay? And alloys are actually also practical examples of, homogeneous mixtures, because it's just a solid material. But that particular material is made up of a combination of different metals, okay? Now, you have got, brass, which is actually made of copper and zinc, bronze, which is made up of copper and tin, stainless steel, which is made up of iron and carbon. But also, bear in mind, the alloys actually are the main reason why we have alloys. It's based on the physical properties. On its own, copper, as an example, is a corrosion-resistant type of metal. But then for a particular purpose, you need a corrosion-resistant, and then you also need maybe a stronger metal. So a combination of the two will give you both properties, which is ideal or fit for that purpose. So that's the reason why there's a wide range of application in terms of the mixtures, which says then there is a need for us to actually understand. And then the second category of mixtures is based on the heterogeneous mixtures. Okay, we have said the word hetero means non-uniform. So a mixture that has got a non-uniform composition is typically a heterogeneous mixture. Okay, so what's so special about, or what distinguishes a heterogeneous mixture from the other mixture which is uniform, is that the components that make up these heterogeneous mixtures, they are not in the same phase. And as a result, we can easily distinguish the individual components that make up a heterogeneous mixture, right? Okay. Now, having said that, you can have, look at, the example there that's given, which is, I think it's oil that has low density, it's floating on water, and as a result of that, we can actually distinguish between these two components that make up that mixture, right? Okay. So examples of, heterogeneous mixtures as we know them in real life. We've got emulsions. So an emulsion is actually a mixture which is obtained when one liquid is shaken up with another one and they do not dissolve completely, okay? E.g., for example, we have salad dressing. In salad dressing, we've got different liquids. Now, even if you shake it, those two, they'll mix, but at some point, they'll be separated. One will either be floating, with some, suspensions in terms of, solid components within that mixture. So these are typical or common, everyday type of mixtures that would want to make, reference to. And then also we've got a suspension, which is a mixture of solid floating in a liquid, which has to do with a very important property that we'll discuss in detail, which is density. Right, okay. Now, having said that, we get a sense in terms of classification of matter, in terms of pure and impure substances, your elements and compound being variations of pure substances, while in terms of impure, we've got mixtures, which have got two categories, which is the heterogeneous as well as the homogeneous. And we've managed to look at one at a time, the properties of each of those types of mixtures. For now, let's take a short breather, and then we continue discussing our, very interesting, aspects of classification of matter. Let's take a short break for now.